Hi guys, welcome to your Quadratics Regents review. The Regents requires two things from you when it comes to quadratics. You have to be able to factor quadratic expressions, and you have to be able to actually solve quadratic equations for values of x. So the first thing I'm going to start with is a binomial, and this is probably the most procedurally straightforward of the quadratics. An example of a difference of perfect squares looks something like this. This is a binomial because it has two terms, but it's a difference of perfect squares, a special kind of binomial, because both the first term and the second term are perfect squares. When we say perfect squares, what we mean is that we can break down each of these into two identical factors. I can break down x to the fourth power into x squared times x squared, and I can break down 36 into 6 times 6. In both of these, we've got two identical factors. The way you factor something like this is simply to write two conjugates, one with the two square roots of the perfect squares added together, and then one with them subtracted, one from the other. Now, in this case, we would have to stop here because at this point there's nothing else we can factor. However, in some cases, we get a problem that asks us to factor something completely. And that's kind of a hint to us that we're going to have to do multiple stages of factoring. So let's look at something slightly different where we're asked to factor completely. Say, for instance, since we also had an x squared there, and we were asked to factor this difference of perfect squares completely. The first thing you want to do whenever you're told to factor something completely is just to check if there's a GCF, a greatest common factor, that we can take out of both terms. In this case, there is. I can factor out an x squared out of this, right? Because this again is x squared times x squared. And I can factor out an x squared out of this because this is 36 times x squared. Both of them have an x squared to spare. So my first step is I'm just going to divide out that x squared, and I'm left with x squared and minus 36. Now for the second part of the factoring process, I see I still have a difference of perfect squares here. So I will write it as two conjugates, one with the square roots added, one with the square root subtracted. And this is the completely factored form of that binomial. That's a difference of perfect squares. The next type of quadratic, which you will have to factor, or you will be expected to be able to factor, is what I like to refer to as a simple trinomial. It's a trinomial that doesn't have a leading coefficient. So what I mean by leading coefficient is, say for instance, we have this trinomial. If there were a value in front of this leading term, the first term, we would call it the leading coefficient. There's none. We can assume that this is 1x squared. And so the way that we factor this will be different than the way we would factor it if there were a leading coefficient. In any case, it's always good to try to go through the steps of factoring and see if they work, and if they don't, you can go to other options. But this is like the simplest form of factoring. So we're going to always test to see if we can factor something in this way first. This is called the ABC method. And in fact, because we don't even have an A value, because we don't have a leading coefficient, we could almost just call it the BC method, because we're looking for what adds up to B and multiplies to C. Don't forget that negative, it's important. We're looking for two values that add up to B and multiply to C. When I first did this problem, I was tempted to think they might be the numbers 2 and 3. But the problem with that is that 2 times 3 would be positive 6, not negative 6, which is why I said the negative was important. In any case, these values, the numbers that add up to positive 5 and multiply to negative 6, end up being negative 1 and positive 6. So the factored form of this will just take these two values and place them into binomials with an x term at the beginning of each. So here's our negative 1, here's our positive 6. If you want to check that this is indeed the factored form of our trinomial, you can FOIL these two binomials. So we would do x squared, x times 6 would be plus 6x. Then we do negative 1 times x, so minus x, and negative 1 times 6, negative 6. Combining these like terms, we'd end up with x squared plus 5x minus 6. So you could see it works. Sorry if that cut off a little bit. But you could see it works, right? Like this is the factored form of that trinomial. If we multiply our two factors together, we'll get the trinomial again. That's the simplest kind of trinomial you'll see. And really all you have to do is look for what adds up to b and multiplies to c. But how about if there is a leading coefficient? Let's look at an example like that. So let's say, for instance, we have 6x squared plus 5x minus 6. We have a leading coefficient. Now, it's not going to be enough to look for what adds up to b and multiplies to c. We're going to have to add in a couple more steps here. So again, to work on your identification skills, to think about like what method should I use for which trinomials, just remember, if you see a leading coefficient, you will not be able to do that ABC, really simply looking for the pair. You won't be able to do that method. In any case, we're going to use the same skills that we used in the previous method. Instead of just looking at our b and c term, we're going to look at our b and then AC term. The AC term is a times c, so in this case it would be negative 36. And our b term is 5. We're going to again look for what multiplies to AC and adds up to b, but we're not going to put them directly into binomials just yet. I like to at this point draw myself a box, because you might remember we used to FOIL in a box. We used to multiply two binomials in this box, right? We would line up one binomial here and one binomial there and multiply. But this is also really useful for factoring, because if we can place our trinomial into this box, it's easy then to see which factor is multiplied up to it. So we start by putting our x squared term here, constant there. But now we have to think, how would we split up that middle term? Well, the way we split it up is by thinking about what adds up to 5 and multiplies to negative 36. In this case, the two values we're going to get are positive 9 and negative 4. 9 times negative 4 is negative 36. 9 plus negative 4 is 5. So I'm going to put 9x here and negative 4x there. At this point to factor, all we have to do is find the greatest common factor of each row and column of our box. So here the greatest common factor is 3. Here it's negative 2. And we can check, right, that it should be negative 2 and not positive 2, because we need whatever multiplies on this end and this end to multiply to negative 6, right? So if this is positive 3, that must be negative 2. Now the rest of it becomes a little bit easier because we can use this same reasoning. What times negative 2 got me negative 4x? Well, 2x. And what times negative 3 got me 9x? 3x. So I end up with these two binomials, 2x plus 3 and 3x minus 2. You may be wondering where the plus sign is. Well, if it's positive, if there's no negative here, we assume it's addition. So I end up with my factored form, 3x minus 2, 2x plus 3. Okay. At this point, I'm going to take a moment before I move on to the next method of factoring, because I want to talk about what it would mean to solve this. Say, for instance, this were an equation and it were set equal to 0. That's usually how they're going to show you quadratic equations. If we wanted to solve this, factoring would just be the first of two steps. After we factored, we would know that this expression is equal to 0 when two things times each other equal 0. One of them, or both, must be 0. That's kind of a rule. You can't multiply any two numbers and get 0 unless at least one of them is 0. And so we use that rule to solve now for x. I'm just going to erase some of this other stuff so we have space. But either this equals 0, so either 3x minus 2 equals 0, or 2x plus 3 equals 0. So I'm just going to solve both of those equations. In this case, I would add 2 on both sides, 3x equals 2. Divide by 3 on both sides, and I'd get x equals 2/3. Hope you can see that. For the second one, I'll subtract 3 on both sides and have 2x equals negative 3. And then I'll divide by 2 on both sides and get x equals negative 3/2. So these are my two answers. Let's talk now about using the quadratic formula. It works for anything. If you ever want to solve for a value of x from a quadratic and you have you've tried different factoring methods and nothing's working, the quadratic formula always works. And it's actually really easy to set up. It might just be a little bit challenging to simplify and evaluate. If you're really stuck on a quadratic problem that asks you to solve, setting it up will get you most of the way there. So the quadratic formula is derived by taking the general format of a quadratic, right? Like this is the way that quadratics look. I've replaced the numbers that you could have, the coefficients and the constant, with letters. But this is the way it looks usually. So the way that we get the quadratic formula is we take this and then we isolate x. We solve for x. We do a bunch of algebra. In fact, we use the completing the square method, and we get x by itself. And once we do all that, we get x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, it's complicated looking, but it is given to you on your Regents reference sheet. So it's not something you have to memorize. It's just something you need to know how to use and when to use. So say, for instance, you were working on that trinomial equation we had before, and you were on the Regents and you're super stuck on it. You were trying to factor, but it just wasn't working out for you. In that case, you could use the quadratic formula. The first step would be to find your a, b, and c values, because we're going to need to plug those in. So a is 6, b is 5, and c is negative 6. And the second step would just be to take those values and put them where they would go. So like 5, take 5 and put it right where b is, all in parentheses. It's good to keep it in parentheses. It keeps it really neat and it makes it clear what's going on. So we have x equals negative 5 plus or minus the square root of 5 squared minus 4 times a times c. You see why the parentheses are good now? Because it makes it clear that I'm multiplying. All over 2 times a. Okay, if you just do this, if you identify a, b, and c and replace a, b, and c in the quadratic formula with those values, you're going to get a lot, if not most, of the points from the question. So please, 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 if you are stuck on a problem that looks like this, a trinomial, use the quadratic formula. All right, at this point, we're going to evaluate this expression. I'm just going to give you some pointers on how to do that. I don't have a lot of space left, but what you want to do is work underneath that square root first. So 5 squared minus 4 times 6 times negative 6. So I would do 5 squared, that's 25. So here, I'll just write negative 5 plus or minus the square root of 25. And then negative 4 times 6 times negative 6 ends up being 144. All over 2 times 6, 12. I end up getting 25 plus 144, which is 169. The square root of 169 is 13. So I end up with this, negative 5 plus or minus 13 over 12. Okay, that's nearly done. But you notice this plus or minus symbol? That means that one of the answers, remember quadratics have 2 answers, one of the answers is if we added negative 5 and 13, and then divided by 12, and the other answer is if we subtracted negative 5 minus 13 over 12. If you evaluate this, you end up getting the same exact answers that you got last time. Negative 5 plus 13 is equal to 8. 8 over 12 is 2 over 3. So x equals 2 over 3. Or x equals negative 5 minus 13, negative 18 over 12, negative 3 over 2. All right, that is the quadratic formula. I'm going to save completing the square for another video because this video is getting quite long and completing the square is one of the coolest ways of factoring.